All right, so now I want to talk about heating and cooling curves. So heating or cooling curves or diagrams, or there's a couple different words for it, but I think you're going to see this most often, heating or cooling curve. So before we go very far, I want to go ahead and label this. So the y-axis is here, draw a straight line if I can. The y-axis is here, and then the x-axis is here. So the y-axis is going to be temperature in degrees Celsius, and the x-axis is going to be time. You may also see this as energy or heat, but most of the time it's going to be time. So here's what's going to happen. So let's say that you have an object, you have a container of water. This is pink water, and you have a fire under it, and this is sitting on some kind of stand. Let's erase the stand. So we got this fire under here that's heating this up. Well, that's what we're showing in this graph, is what is happening to this water as it's in here. So when it begins, it's actually a block of ice, or a lot of ice, lots of ice, and it's got a fire under it. So that's what's happening here. So this ice is in the state of matter that we call a solid. And as the temperature increases, you can see that over here, as temperature increases, as energy is increasing, the time that it's over this fire, then the solid is increasing in temperature, increasing in temperature, increasing in temperature. And then it gets to a point right here, for if this is water, let's just say that this is water. If this is water, then this point right here is 0 degrees. And the reason I know that, even though this is not labeled over here on this side, I know that this is 0 degrees because I know that a solid starts turning into a liquid, which is what's happening on this line. It does that at 0 degrees Celsius. So this point right here is when you'll first start seeing a little bit of liquid drop. So you'll see the solid turn into a liquid. That's when it is getting at this point right here. So it's right at or right above. If you're looking at this with a thermometer, it's going to be floating around 0 degrees Celsius. And then time goes on, 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 time goes on. And as that's happening, nothing is changing in the temperature. The temperature is not going up, it's not going down. And the reason is because more and more of these ice cubes down here in the cup are turning into liquid, and this is slowly filling up, and ice cubes are slowly disappearing. So this is what we call, it's a super scientific term, hopefully you've heard of this before, it's called melting. I'm going to draw this in a different color. Melting. If we're going from a solid to this next stage, which is liquid right here, from a solid to a liquid is called melting. And so, we get, once they liquid, so I'm sorry, let me back up. So this area right here, this line, is where the where the solid is slowly becoming more and more and more and more liquid, until right here, it's still 0 degrees. Right here at the very end, right there, is your last little flake of ice, last little flake of solid water. And after that's done, boom, the temperature starts increasing, 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 increasing. And guess what this area right here is? That area right there is called boiling point. This is the boiling point. So this is, let me stay with the same color code, sorry, color scheme. Boiling. So this is the boiling point, and this is where the liquid starts turning into the next state of matter, which is, you should already know this by now, is a gas. And this temperature right here, all this is 100 degrees. It's 100 degrees because that's where boiling happens. And this liquid stays the same temperature, stays the same temperature, stays the same temperature until the last little bit of water is, liquid water is there. And as soon as that liquid water is gone, then that water, which is still water, even though it's a gas, it is turned into a gas, and it is going to increase. So steam, not all water is the same temperature. So all liquid water, it's not all the same temperature. You can think of like a super cold stream. If you've ever jumped in and done like a polar bear plunge or something like that, that water temperature is right here. Right before the water starts to boil, that's right here. That's a huge difference. That's 100 degrees of difference, 100 degrees Celsius of difference. And so water can be different temperatures. The liquid can be different temperatures. And then gases can as well. As gases get hotter and hotter and hotter and hotter, you're going to see it coming up, up, up to there. So this is a heating curve because as time goes on, it is getting hotter. And I'm not going to go into detail about this because it's the same thing, but if we were to draw this, if we were to be super accurate, we would draw this like this, starting as a gas going down, and then here, can't get the lines to work, here, here, and here. That would be a cooling curve, which if you'll notice is the exact opposite of what we've got here. But to keep things simple, a lot of times what we'll do is we will actually just write the opposite down. So if a gas is cooling off, it gets to here, this is called its condensation. Condensation is forming, condensation. I'm just going to write condense because I can't write condensation all the way there. So this is where it's condensing. That means turning from a gas into a liquid, and it cools off, it cools off, it cools off until it becomes a liquid. And then once it's a liquid, if it keeps cooling off and losing energy, then we get to this point, which is its freezing point. If it's going this way. Another word for boiling point is evaporation or vaporization. That's probably going to be the best word to use, but if you were to understand evaporation point or a boiling point, that's okay too. Any one of those are fine. So yeah, that's it. That's a heating curve, cooling curve. It's hard to think about this with water when it comes up to this point right here, because when you boil water on your stove, it just kind of disappears. It seems like it disappears, but it's still there. And in a closed system where that gas can't leave, we could continue to measure that gas, and the temperature would continue to rise after all the liquid water is boiled off. So yeah, this is heating and cooling curves for water, and the heating and cooling curves for all kinds of objects, all kinds of substances looks similar. Again, sometimes it will look like this for a heating curve, or it will look like this for a cooling curve. But if you want to just draw them like this, and that's okay, but know the difference. Know that one is a heating curve and one is a